So look, guys, you guys are lucky to be at this conference watching. This is the launch of the Atomicals protocol. You came to an Ordinals Summit and you're leaving as being one of the first to market to know that this exists. It's actually launching right now. And it's gonna, you're gonna have what? I'm gonna let you say what you need to say, but you guys are in on the ground floor of a new protocol. That's all I'm gonna say. Art of Satoshi, thank you so much for being with us, and yeah, I'm excited. I'm gonna let you take.
Thank you, Raphael, for the introduction. I'm really excited to be here, and it's an honor to present at the summit here. So thank you so much for having me, and I hope to share something really exciting with everyone here.
Awesome. The stage is yours.
Thank you so much. So this is Atomicals. This is digital matter organization. This is a comprehensive solution to organizing digital objects. We call it digital matter, like bitmaps is digital matter theory. You may have heard that being talked about. We have ordinals, we have naming systems, we have all kinds of new protocols emerging. And this is Atomicals to help complement and build on top of what exists. First, I'd like to talk about what are the main problems that Bitcoin creators face to really understand what we're trying to do here. I'm going to go quick because we have so many slides, so many things to cover, and I want to leave enough time for questions at the end. So the main problems are there's proprietary APIs, which lead into vendor lock-in, over-reliance on proprietary APIs. It costs a lot for developers, and there's different views of on-chain data. This causes significant problems for developers who want to innovate because they're trying to decide what APIs to use, and they're all different in their own little ways. Unreliable indexing. This, significant values of assets are being put onto ordinals on Bitcoin, and with unreliable indexing, we don't really know if you're going to get an ordinal number that's positive or negative. For example, that's one of the things that came out of one of the edge cases that was discovered. It's difficult to compose and build on top because there's just so many changes, and the building blocks are just rather low level, which is great to have gotten started with inscriptions and to be able to bootstrap this entire economy. But we really need something more, because there's a lack of higher order structure right now. Okay. So there's also limited on-chain metadata. So for example, collections must be manually uploaded on GitHub, and they must be updated across dozens of marketplaces, and hope that there was no error in the process. Very expensive to fix errors. And the structure of ordinals leans very heavily to a single file usage, which means there's off-chain conventions and proprietary indexing conventions by different marketplaces. This leads to less control for creators, because without an access to a robust high-performance indexer, then we end up depending on marketplaces and the services that are offered by these proprietary walled gardens. Less profit, of course, because then we're over-reliant on specific services and marketplaces and their indexers, their APIs, their wallets. Okay, so what are Atomicals? Well, Atomicals is the simplest, most flexible way to create and organize digital objects, digital matter. So we're standing on the shoulders of giants, complementing and organizing all the data I mentioned earlier: ordinals, bitmap, the ARC-20, and of course Atomicals, because Atomicals is a fully standalone protocol, but also complements what exists and what will exist in the future. But why Atomicals? To permanently take back control over our digital sovereignty and solidify Bitcoin as the main proof of work beacon. Bitcoin is a revolution for freedom and sovereignty, and Atomicals is going to help put tremendous value on the chain and further solidify the main proof of work signal that we have on planet Earth as the main primary proof of work blockchain. The agenda for today, quickly, is we're going to introduce the theory. We're going to introduce Bitwork, which is minable tokens, containers, which is just another name for a collection standard, and so much more, and ARC-20, which is Satoshi-Faithful Colored Coins. Let's begin. So a digital object, or atoms, are basically NFTs encoded in the familiar fashion to ordinals, except with the simplest possible rules that can work, treating the UTXO as a colored coin. There's multiple file support using the CBOR format, which of course is basically JSON compatible. So you can have an image.jpg in an atomical, you can have a metadata.json in that same atomical, and you can have any other key value data during the mint and later. That's the immutable state. So upon mint, we can always refer back like a digital artifact. We have the images, the PDF, video, any document has immutable state that's burned permanently on that transaction. Then there's dynamic state. This is where we depart. Is each transaction, each transfer allows data to be updated. It's a key value store. You can update files, update any kind of data. It's just an object. We have things like freezable properties. So you could lock a property. You might have, let's say in a game, you might want to lock some scene or some weapon is not able to be used until some future point in time. You can lock a property and to a certain block height. So everyone else has to converge on the same consensus for that property having a certain state and a certain value until a certain future point in time. You can also have immutable properties, which once set, they're set forever. We'll talk about this later when we get to containers, why that's useful. We have an event feed. Every atomical can publish its own event feed. You can have your own Twitter feed or social network built on an NFT. If the NFT is your profile, you can have a feed that other indexers, other services can just follow and trace through all the things that are happening for that token. It doesn't just have to be in social use cases. Anywhere there's a stream of data that you're interested in, we can now synchronize on planet Earth. Parent-child relationships. We can have any number of parents, 0 to any number, that must be spent as inputs. So you can create complex chains of dependencies by including other atomicals as required inputs to be able to have the mint succeed. Okay. Well, the use cases I just mentioned here, we have things, everything can be tokenized. Community as token, web profiles, websites as token. Any file, any collection of files can be tokenized. Okay. I'm going to demonstrate, well, this is pre-recorded, but here's a demonstration in 20 seconds how to create a fresh wallet and mint an NFT image in about 20 seconds. Here we're going to mint the Bitcoin logo, bitcoin.png. We're going to create a wallet done in it with the command line and issue the mint. A QR code is presented, expecting payment. Once the payment goes through, the transaction, the reveal transaction, sorry, the commit and the reveal transaction are made, and you've minted the NFT in about 20 seconds from scratch with no prior wallet, no prior anything. Okay. And so you can see here how easy it is to create an NFT and start from scratch. The regular person can get going in literally 20 seconds. To get the latest feed of Atomicals, we just go CLI list. You get a list right here. You can see here some important details is that we have something called an Atomicals block tip. So we introduced the concept of an Atomicals block header, block hash. So each Bitcoin block is taken and concatenated with all the Atomicals transactions in the block, and we create a Atomicals block hash. And so you'll see that this is useful for synchronizing across indexers, because as long as the Atomicals hash matches for the current block, then we know that everyone has the same snapshot of the data. So that's one thing you see here. We see the atomical count. We've minted 1, so there's an atomical count of 1. The first is the atomical number 0, and we can see there's this atomical ref that is also the atomical ID. And so in this scenario, we can see that we'd be able to get a feed of the atomicals and display them for in the terminal here. And here's the image data you can see of the Bitcoin PNG. Okay, moving on. And to update the dynamic data, so I mentioned there's a key value store. Let's go and update some data and see what that looks like. Okay, so we have here the set command. We take the atomical ID, which can be an alias or other things later on, but we'll just take the atomical ID, set a path name, and then the key value hello world, and we'll make a lucky number 777. And this is what it looks like to update on the command line. QR code is displayed, and we make a payment to do the update. Okay, just give it a moment to see. Okay, and you see here that once the payment goes through, everything's fully automated to update that atomical with the data. Once it's confirmed, we're going to see that the data is updated. And here it is after we query, after it's been confirmed. We get the state using the CLI state command. We can see that for the namespace called path name, we have the latest snapshot. The hello value, the hello key, has the value world. We can see the transaction ID, the height, even the transaction number in the global Bitcoin blockchain where it was updated. Yeah, there's a lucky number right there, value 777, and then once again the path is repeated to show that the path was just updated recently. So to update the data again, we can now issue another set command to the same path. We update our lucky number to 888. And we set something called a permanent immutable property with the caret, the arrow that's pointing up. Once we set any property with the caret, it's locked forever, like forever. So it must be used with care, but it could be really useful if you have an atomical where you want to attach maybe artist signatures, or maybe you want to make it a member of a collection or container later on. I know I'm getting ahead of myself. And then you can lock it to that container forever. So even if it gets transferred and updated later on, this permanent property, well, it remains exactly fixed. And we have this lockable property. So anything with the @ sign and then a colon and then the block number is one of those lockable properties or freezable properties that will be frozen until that future block height. So we can achieve consensus on that. And here it is after it's confirmed. You can see lucky number was updated because it is a dynamic property that can be updated. And then we have the permanent property. So even if you try to update that permanent property, it's the convention is no, it's ignored. And lockable property, of course, cannot be updated until the freeze time is over. You might not know when you want to freeze a property. It could be like a game or rounds in some match or some social game. And you could just define the freezable property up front with the @ sign and not provide a block height. And you can update it like a normal dynamic property. But then when you're ready, you could lock it to a future block height. Okay, now we're going to shift gears to Bitwork. That was what I just explained, was kind of the very quick tour of how to mint and create and update the base atomicals. Now we're going to talk about Bitwork, which we're going to use to build on the next things. Okay, so Bitwork is proof of work, can be used for any atomical mint. We can set a vanity transaction ID using the arguments with the Bitwork C parameter. It's basically saying what we want the prefix of the transaction ID to be, and it allows us to prove that energy was burned in the process of creating that atomical mint. We can choose like a 1-letter prefix to many letters, and we'll see what that looks like next. The use cases, of course, for this are introduce an element of randomness into mints. We can organize communities around vanity TXIDs and refs, and of course, it's just bragging rights if you have a really cool ref or prefix that's resonates with your community. We can do content ranking based on the costly signal theory. So we could rank content based on how much energy, provable energy, was burned. So remember that event feed I talked about before? Well, you could have profiles that are interacting, publishing, social posts, and we could upvote them with provable energy burn, or even inject the demand energy to be burned to mint them in the first place, and then rank everything trustlessly. Throttle and limit token mints. It works as a spam filter, of course. This is the original hash cache paper by Back, and one of the ingredients of the Bitcoin proof of work system. So we turn every token now into something that can be mined. So here's an example. Let's get to it. Bitwork. We want to mine, let's say, the ref prefix of cat, or the TXID prefix of 62B4, which encoded in Crockford base 32 is cat, C-A-T. Let's see what that looks like. We do a regular mint NFT. In this case, the atomical is just hello equals meow, and we set the Bitwork flag to cat. It presents the QR code to make the payment. And then once that's paid, the mining process starts until all client side, by the way. None of this there's no proprietary servers. This is all done client side, local, and interacting with the open source indexer that we'll talk about later. So once the payment's made, we're going to see how the mining looks. Here it goes. Okay, so now your computer would be searching for the prefix of cat at this difficulty level of 4 hex digits. It's about a minute or two. And you can see here some estimates of, if you have a longer prefix, of how long it would take. You can go out as far as you want, and it is our hope that GPU mineable tokens are going to emerge. Someone just needs to take the library of the CPU miner that I've written here and port it to GPU mining, and we can achieve much, much larger prefixes. Okay, so in this case, you see the prefix was found, it broadcasted the transaction and created it. And here's a screenshot of still for what happened. So Bitwork matches the TXID, broadcasts the atomical ID is the commit TXID, not the reveal like atomical ordinals. There's reasons for this later. I'll talk about why Atomicals uses the commit transaction ID as the identifier for the Atomicals. There's a very important reason for this. Okay, but you can see here, once the token has been mined, we query the feed, and we can see that atomical number 1 has this transaction ID starting with 62B4, and it has the atomical ref when it's encoded as Crockford base 32. It has cat at the beginning. Okay, so this is an example of what it takes to mine. You'll see the Bitwork parameter on the atomical is set. If you look below, it says Bitwork C, which stands for Bitwork commit, and Bitwork R stands for reveal. So you can also add proof of work to the reveal transaction. In this case, it's set to null because we did not add proof of work to the reveal transaction, just the commit, because we wanted that really cool vanity TX of cat. That's why we did it. Okay. Moving forward, building upon Bitwork and what we've done so far, we introduce a collection standard called containers. It's an on-chain collection standard, organize anything, atomicals, ordinals, bitmaps, everything and anything, add, update, delete items all in one go or incrementally, and permanently sealable. So once a container is sealed, it can never be changed. The UTXO is effectively burned, and there's a snapshot in time with the latest state as it was when it was sealed. You can imagine artists and collaborators attaching their signatures or their messages at the end when they finally created the collection to kind of sign off or give their autograph to the collection, and it's sealed permanently into Bitcoin land forever, untamperable. Well, a collection standard gives us the opportunity to have on-chain metadata. So we have all the items are in a standard format. We don't have to go to any other marketplaces or proprietary service to update a file and then hope they make the updates without error. No, we have an on-chain standard. It's done. Everyone gets the same data replicated. But that wouldn't be enough. We need a container name service. So everyone agrees on the name for the collection. It's a globally unique names identified by hashtag. First is first. In order to prevent name land grab, name grabs, and squatting, we must use Bitwork. At least 3 letters to slow down the container name registration. So someone could not just easily register thousands of these container names. They're going to need to spend significant CPU time. Oh, at least 3 letters per mint to claim a name. And they have to be the first, of course, to do it and pay the on-chain transaction fee. Examples would be like Bitcoin Funks or Gemini Warriors. You can really be any name up to 64 characters long, as long as it doesn't include things like emojis and all that. But any readable container name is up for grabs. First is first. Okay, that's how the container name service works. So let's do a mint and claim of a container name and see what that looks like. So we mint-container, we call it my cool container, and we set the Bitwork to just MYC, just because. We can use a hex prefix, but we can make it anything. We'll just use this for a demo. Here we go. It's waiting for the payment, and it's going to mine the Bitwork prefix. That's their spam filter. That's our throttling mechanism. And once the user successfully mines the prefix, the container will be in the registration process. I'm going to talk about next what that means. Okay, let's just watch this go through. And here, I just sped it up. Here's what happens after the container is minted, and we query the atomical. We can see here that the container is pending candidate. So the atomical is the leading candidate for the container. We must wait 3 blocks after commit to achieve confirmation. Now, let me explain what this is. In order to have a robust identity name system, we have to solve for front running. We can't have a system where some adversary could just monitor the mempool to see all the interesting names, like container names being taken, monitor the mempool, and then front run all the cool collection names, and then mine those names themselves while they're monitoring the mempool. We can't have a system that allows front running. It just won't work at scale. It's not workable long term. So what we do, remember I said that the commit ID is used as the atomical ID? That's why. We actually use the atomical ID, the commit ID, as authoritative. The transaction number of the commit is what determines who gets the name. So for example, if I mint my cool container, I make the commit, I can wait a block for a confirmation, not reveal that transaction. So no one knows, it just looks like a regular Bitcoin Taproot transaction, right? Well, I can wait for the confirm and then reveal it after. So if anyone's monitoring the mempool, they'll just see the reveal. They won't be able to go back and front run me because I already have the commit burned on chain 1 or 2 commitments before. So they can't actually front run me and take that container name. It's too late. They got to see what I revealed. Well, I'm the first leading candidate, so I get the container name. No one else can because I provably am the first. And so that's why we must wait 3 blocks for the commit, because someone could have minted the same name within that window, and we're just waiting for them to reveal it before us. If they don't reveal, if no one reveals in that window, then this pending candidate becomes the verified container, and it's permanently belongs to the minter. Oh, and here it is what it looks like. It just says after 3, it says status verified. And then you see this $ container appears now at the top level atomical to indicate that it's a container and it's been granted that name. We can see a summary at any time on the command line of the containers we own, summary-containers. You can see here the atomical number, the container was requested, and the status, and the verified ID, which is the same atomical. So you can always take inventory of the containers or the collections that you have minted. Okay, let's add new items to container. So we have the standard being used across Ordinals marketplaces. We have edition numbers or identifier, then the ID, it's a metadata. This is just a snippet. This could be hundreds or thousands of entries long. And we just do a yarn CLI set And we use the hashtag mycoolcontainer because we already claimed the container. So now we can use, in place of the atomical ID, we can now use the container name, and the command line knows that we're referring to the container and resolves the atomical ID underneath. We're just going to add to the items namespace the contents of the file items-sample.json, and we mint it, and it'll be updated just like updating any data on any atomical. It's just in the container context. We're literally building on everything we've created prior. And finally, we can seal a container permanently. We just use yarn-cly seal, and it gives you warnings, and it requires you to type, yes, please seal permanently, or at least it says seal permanently. So, because if you use this, the container is locked forever. It effectively becomes unowned, and the latest snapshot will be there forever, immortalized on Bitcoin. Okay. Here we introduce, shifting gears a bit from NFTs to colored coins. Introducing ARC-20, the colored coins that are truly faithful to Satoshi. And we humbly say that if Satoshi were to create colored coins, he would do it this way because 1 Satoshi equals 1 Satoshi. Every token mint is backed exactly by the Satoshi units that represents the total supply, which means the lowest value of any token is exactly 1 Satoshi by definition. We can split and combine UTXOs just like normal Bitcoin. It's like the tokens are hovering on top of the UTXOs, be it taproot addresses or legacy addresses. Any address type carries on the value of the colored coin. We have direct minting and decentralized mint modes. You might recognize the decentralized minting from BRC20, and we're going to talk about that shortly. But first, a token standard would not be complete without a ticker name service. Similar to the fashion of container names, we have globally unique tickers identified by $. First is first. We must use Bitwork, again, to slow down the ticker claims for all the same reasons. And of course, we really probably do want a very nice vanity Atomicals reference or transaction reference for this, because it's you're making a token, it's going to be that much more special with your own prefix. Ticker examples, of course, anything you can think of, except you can't use hyphens or dashes in the name. They have to be tickers, and they're limited to 21 characters instead of 64. So let's talk about the direct issuance. So a team may want to issue a token directly, traditionally like ERC, Ethereum tokens. They'd issue some supply, and then they distribute it to whoever they want in whatever fashion they want. And so that's possible here. We use the mint FT command. We take the ticker mytok in this case, and we issue a supply of 2,300 units, and that's the number of Satoshis, but the number of units. And hello equals world is the data. Probably we'd use like icon.png or something like that to give you an icon. And then we'd even attach metadata. I haven't shown it here, but you'd want to attach metadata probably about terms and a website if you have one. But we don't do that here. And of course, we have to attach the Bitwork to take the token, and we do. Once we've minted through the process I've already shown before, you can now see that you have the same ticker, $ ticker, my tick. It says the ticker candidate. This is a verified and claimed ticker for the current atomical. And this is a fungible token atomical with a total supply that's listed, and it's in the direct mint mode. And so we can do a balances. Doing a balance, you can see the primary address locally, and we can see here we have the atomical ID, the confirmed balance we have, a number of UTXOs that sum up to the confirmed balance and the ticker you own. Okay, now that was direct issuance, but what about something more, let's say, decentralized? Well, we have that too. Well, the difference is we initialize the fungible token with the init-dft command, the init decentralized fungible token command. We would claim a ticker. In this case, the ticker is my decentral. And we say in the next parameters, it says, for each mint, give out 1,000 units there's up to 20 mints that are allowed. And minting starts at the block height, in this case, 800,000, 8,100. And some data, hello world, which once again probably would be an icon instead. And we attach some Bitwork because once again, we need to attach some Bitwork to claim a ticker name. And then we've added an optional parameter here called mint Bitwork. What this is optional. In BRC-20, you can just claim the token units of a mint just by making a transaction. But that's kind of ripe for abuse, and someone could just blast many transactions and pay all the fees and mint a whole bunch of supply for themselves. Instead, what we really want to do is to make the person do work. Kind of like how you have to mint Bitcoins themselves. Well, we can force Bitwork to be added to the claim later on, and we can specify the prefix. In this case, it says we must match 4 number 7s in the TXID in order for a person to be able to claim the 1,000 units. Not only do they need to pay the Bitcoin transaction fee, they need to put up 1,000 Satoshis that represent the units of this token, but they also need to expend some energy to prove that they did some work so that they can claim the token. Well, once it's been initialized and that you've gone through the 3 confirmations to claim the ticker, well, anyone can now issue the mint-DFT with the ticker name, and a QR code is presented. Once they pay, their local computer will start mining for those 777 prefix to attach the Bitwork. And if it's all successful and hasn't been minted out, then the user will receive the tokens that are granted by the protocol for the total supply. And then from then on, the decentralized fungible tokens behave just like the direct issuance, except they were just issued in the decentralized mode. Transfer and split works works just like Bitcoin. So you can have any number of inputs of any colored coin, any fungible token, and you could split them out in any fashion as well. And use the transfer FT command with the ticker. I don't show it here, and it's just kind of the technical detail, but the key is as long as the output quantity matches the input quantity, like the total value of the incoming total value of the incoming Satoshis equals the total value of outgoing, then all the UTXOs are colored just like Bitcoins. If a mistake is made, yes, the user can burn their own coins if they, for example, try to inflate the supply and create an output that has, say they only had 1,000 units of this token and they try to create 2,000 units for themselves. Well, that is effectively a burn because it's false. So as long as the output quantity is conserved with the input quantity, all is good, and it works just like Bitcoin. So it sounds scary, but it's not, because it's very easy to actually just ensure that the input and output quantities match, just like Bitcoin itself, and wallets, and we'll build in just the validation to make sure that's done, and so users are not going to accidentally inflate or try to cheat the protocol, which just won't work. And that's why we call it Satoshi-Faithful, because it's like the coins hover on top of the UTXO, and they can be split and recombined in any fashion, just like the native UTXO. And so there's really it's like a zero overhead coin, but it has the power of Bitcoin, and backed by Satoshis themselves. We could add decimal placements in the metadata. You could say there's a number of how many decimals, but we just say there's only 1 decimal or 0 decimal places. Another kind of not immediately obvious benefit of this technique of using Satoshis to back the tokens is that scammers that just want to create a token with that have no intention of supporting it or doing anything with it, well, they still need to put up the collateral, right? So in order to mint a token with say 100 million units, that's 1 Bitcoin. They need to actually front up exactly 1 BTC of value to mint that initial coin. And if they're giving this out to people, in airdrops or whatever, they're literally giving away Satoshis and giving away their Bitcoin to the community. And so it kind of increases the requirements of a team to be honest and also to have collateral up front to be able to mint the token. You can't just create numbers out of thin air and then say they're worth something. No, you actually have to have Satoshi units backing. You can see this as Bitcoin is digital gold, and the digital gold is infused into the token. 1 Satoshi equals 1 Satoshi. Okay, the big picture. We've talked about Atomicals Theory, the Bitwork Minable Tokens, and the containers we've gone through as well, and of course introduced ARC-20, which we're really excited to see what people do with. There's one more thing. The realm name system. The realm name system is the first real competitor to the DNS name system that can actually go mainstream. There's no domain suffix. Every name is a top-level realm, or TLR. Globally unique, completely alternate universe to domains. Unstoppable, sovereign, digital identities. The realm name system is encoded as an atomical NFT using all the familiar rules. It's not DNS. It doesn't have DNS like suffixes like .com or .net. It uses the plus to indicate that we're in a completely different universe, a completely different dimension, built from the ground up for the Bitcoin native world. This is your Web3 digital passport powered by Bitcoin. It's digital sovereignty. It allows us to prepare for a post-DNS world. What is decentralization if we all depend on DNS, which is controlled by a handful of organizations from the top that can dictate the terms? DNS is constantly hacked. We can prepare for a world where we don't even need DNS. We're going to start now. It's owned by no one and everyone forever. Everyone is their own registrar, equal playing field. Let's show how we can mint and claim a realm. CLI, mint realm, alpha, and we attach our familiar Bitwork to slow down the registrations. That's all we'd have to do. I'm not going to go through the, paying the QR code, but that's all it is for the command to create and claim your own realm. To resolve the data like you do a whois, like a DNS whois query, just go CLI realm info. And we use the plus alpha to get data about it. You don't need the plus in this context, but I've demonstrated the plus is interpreted as a realm, and it can be used as an alias, just like the containers with the hash sign you've seen before instead of the atomic ID, or the $sign for the tickers can also be used as aliases. But here we're using the realm identifier of the plus. We get the data back. We can see information about the realm. We can see the minting rules, which, well, I'm getting ahead of myself here, but we can see the data about the realm. This is a top-level realm, the full name, and the candidates that were competing for the realm. Because remember, I mentioned earlier, it's so important that we have front-run protection. This is to be a real viable alternative, a competitor to DNS. We can't have a name system where someone could just squat on the mempool, monitor all the name registrations coming through, and snatch up the good names and mine like a block faster, or pay a miner to mine your transaction that takes the name up. We need front run protection, and that's why Atomicals provides this. And this is actually the reason for Atomicals having this this method, is so we can protect names and actually move beyond DNS. And this was the key ingredient. So here we can see the information about the TLR, in this case called alpha. There's one other thing. Subrealm minting. We can organize and monetize communities by issuing subrealms under any other realm. Alpha could have alpha.web. Any subrealm can issue any other subrealm as well. This is like subdomains or sub hierarchies on websites if you want to relate them. But we're going from left to right, not like DNS, which is right to left. You can organize your tokens. Say you own alpha, you could have a website at .web, you could have your tokens at .tokens, or even maybe a social profile. Every subrealm also inherits the same features and can issue subrealms after it as well. So imagine you have a top level realm and you want to organize your team. Well, you can have a team page or team realm, and then underneath you could issue sub realms to your team members, or members of your guild or clan or community. You could organize your bitmaps underneath your realms, and anything else that you can imagine. Remember, everyone is their own registrar. There are no central parties. The use cases for sub-realm minting are boundless, from DAOs to clans, guilds, all kinds of communities, web hosting, social media, authentication, members, loyalty, bitmap hierarchies, and so much more. We can mint sub-realms directly. So the owner of a realm or sub-realm can just use the mint sub-realm command. So in this case, alpha.world. And in this case, we're saying the owner is, you can specify your local wallet. In this case, it's redundant, but I've demonstrated we can spend from different wallets. So here we're gonna mint the alpha.world sub-realm, and the usual process applies. And when it's all done, the Atomical NFT sub-realm is put into the user's wallet. There's just one final thing. Sub-realm has automated minting capabilities. So any top realm, TLR, and any sub-realm allows offering any sub-realm for sale at any price. Uses a pattern, regex matching. Payments can be enforced to one or more addresses. You can set the price for any name underneath. The mint procedure is fully automated. Update or revoke sub-realm minting rules at any time. You can open it up and just sell sub-realms that begin with the letter A, or a set list of names that are available. You might have a group or a clan that you want to form, and there might only be maybe 100 different characters or roles that you want to make available. Well, you can specify that, each have their own price point, or you can leave it open, and you can disable it later as well. And because we can also seal realms and sub-realms like we seal containers, there could be a realm offering or a sub-realm mint, and when it's all done, the parent realm could be sealed forever into its global permanent state, and all that remains are the individual members represented by the sub-realms. That's called claim sub-realm by rule set. And all we got to do first is we do cli enable sub-realms for alpha. We attach the sample rules.json, which is just a file that says for this regex pattern, this is the price, these are the outputs you must pay. Once that's enabled, after a few confirmations, here we go, here's a screenshot. You could see we're basically just using the dynamic data properties of Atomicals. So we can attach data into the sub-realms namespace under a rules variable. There's the pattern you see here. In this case, the pattern is anything that starts with an A, has a certain output requirement. And if that doesn't match, then it falls back to the second rule set at a different price point. So you can have hierarchies of price points. Maybe you want to sell realms that have 5 characters or more are one price point, but anything that's say less than 5 characters would have a different price point. And because you can pay to multiple outputs or expect payments to multiple outputs, you can then offload this to realm registrars and marketplaces, which could set up minting rules and also on the realm owner's behalf, and then attach an output that expects a commission to be paid for them in real time, maybe 5% or whatever, for setting it all up, and then that would be automatically enforced. And once again, this is all the decentralized indexer. There's no proprietary backend that's doing this, no authority. This is just the consensus rules of the decentralized indexer that we all agree on, and because we all agree, it all just works. Okay, and that was the minting. So we'd want to mint by the sub-realm, but not directly by the parent. Let's say, let me back up for a sec. We can mint, if you own the parent realm, you can issue any sub-realm anytime you want, provided you haven't already created a sub-realm or someone else hasn't minted that sub-realm name. You can go and claim anything because you own the parent. But in this case, if you don't own the parent and you just want to mint according to the rules, then you just make a mint sub-realm request. and it'll display, I don't have the slide here, but it'll display in the command line the price and the price and the requirement for that. So if you get the realm, the sub-realm, if you claim it first, then you're going to make a payment to complete the transaction. If you don't make that payment in say, some payment window, then someone else could claim that sub-realm. Obviously, you need to make the payment. And I won't talk about that now, but there's a two-step process. First is to claim the sub-realm. The second is to follow up with the payment, because if you don't make the payment in time, then you will forfeit your opportunity to claim the sub-realm. So here we see, once we've successfully minted, you can see the sub-realm candidates. In this case, this was minted. Here it is. It says, await until the make payment from block height for the payment window to be open with the status of pending awaiting payment. What this is saying is, remember that front running protection I talked about? Well, if you mint a sub-realm and someone else had the same sub-realm in mind, but they haven't revealed the transaction, and if you made a payment before that person revealed, but then they revealed within that 3-block window, well, then you would have lost your payment, right? It could be a lot of money to try to mint a realm, and then you're out that money. Good luck trying to get that back. So we use a two-phase or two-step process with sub-realms, where the first is to wait the 3 blocks to ensure that you're the first to complain, to claim that sub-realm, but then you have 15 blocks after to make the payment. And that payment window is there so that when you're making the payment, you know that you're the leading candidate, that no one else is going to reveal and rug you out of your money. So you have 15 blocks to make the payment, after which the 15 blocks that your claim is expired, you'd have to do it all again, and someone else can go ahead and claim that sub-realm instead. This is the difference with sub-realms versus top-level realms and tickers and containers. We have to have this two-step process, but it works really great, and there's no way to accidentally, with this technique, there's no way to have any problems. That's why we did it this way. And that's the make sub-realm payment. So we can query on the command line with the CLI pending -subrealms, and we get the information of the local user's wallet of which sub-realms are pending awaiting payment. Gives all the information, where at what block height you should make the payment from, and the payment is due no later than 15 blocks later. And so it gives you all the details. But with this command line tool, you can just enter the number you want to pay, and then a QR code is presented. And once the payment is made, then it's all automated. So you don't have to do anything manually. So that's how payment would work from the command line. Once claimed, sub-realms are your property and can be bought and sold just like any Atomical NFT. Use sub-realms exactly like top realms to host websites, files, and links. You can use the / to indicate namespaces or specific files. You can even directly create the sub-realms or enable automated sub-realm mint rules according to any pattern and price point you want. It's your property after all, and no one can take it from you. Join us in organizing digital matter and decentralized everything. Atomicals and Realms launch will be activated on block height 80, 80, 80, or a little under 2 days from now. Activation is from Atomical number 0. It's approximately 1 p.m. UTC this Sunday. Join us at ground 0. Run an indexer. Check out the command line utility. We'd love to hear your feedback. We need your help. A lot of these resources are not yet written. We appreciate your patience. We're going to be putting these together in the next couple days to prepare for the launch. We have a public server up, and we're going to provide snapshots as well as provide help for people to run their own indexers so they're able to get in on the ground floor and help us launch the Atomicals era and organize digital matter with us. Thank you so much.
Hi there, Atomicals. Can you hear me?
Oh, yes. Loud and clear.
Awesome. So thank you so much for your presentation. This is an honor to have you here, and for you to be helping out in this evolution of on-chain economies, providing the world with this protocol is incredible. So thank you very much, first and foremost, on behalf of everyone, for doing this. Now, what's your to-market strategy in order for the Ordinals community to come to understand Atomicals for what it is?
Well, thanks for having me. I really appreciate it. I want to reiterate that this is the community's an inspiration to create this project. About an onboarding strategy, to be honest, we decided to build it and hope that people come and join us in this mission to organize digital matter of all kinds and to see what complements their projects and what they can also leverage from Atomicals. I think the value proposition is compelling. There's a lot of things that the Bitmap community and Ordinals NFT projects are trying to do, and they're having some success with it, but we hope that what we've discovered and what we've built can be even forked by the community to be taken in the direction they want. Our hope, of course, is that we all get together and rally behind building out the Atomicals indexer, because it is decentralized, democratic, open source, and there's no central parties, there's no uneven playing field. So we really hope that people see the message and what we're trying to do for the Bitcoin economy, and embrace that with inclusiveness. And so this is our first message to the community, the Ordinals community, the Bitcoin community at large, to help join us. And this is our part of our outreach to start to educate and also learn from the community of what they'd like to see next, because this is just the beginning. This is not the final destination.
Right on. I got a question from the audience. When interoperability?
I presume they mean interoperability between the other protocols.
Yes, I think that's what they mean. Yeah, they left that. They didn't specify their question, but yes.
Well, that's an interesting question. There's what could be done right now is, for example, if you have Ordinals of a collection of NFTs in Ordinals, you can organize them into containers already. You can organize them into realms. Realms can link to Ordinals and projects. So we can already use containers and the realms to be able to organize what exists already. And for the future, we'd like to take kind of a measured approach to we haven't decided yet, but it would really be interesting to be able to, say, bridge Ordinals and Atomicals back and forth. And that's something that I've actively been thinking about. It would require running an Ordinals indexer as well. So you can imagine like a hybrid indexer, so that both chains or both data sets could be tracked. And then that leads to another higher order structure that I was talking about earlier, that we're lacking that structure. So Atomicals is that, I think, that leap forward to start allowing us to do more with composition and also start to have that higher structure emerge. So we definitely have ideas on what to do next, but that's what I mentioned. There's a couple ways we can already complement and organize Ordinals with Atomicals, and hopefully we can actually do something even more deep with deeper integrations in the future.
Okay, so look, there's a bunch of questions. People have tons of questions, and that's why we're going to let you go a little longer than the rest, because what you're doing is very important. Okay, so what do you think of altcoins? Do they offer significant competition? Will Ethereum survive? Any others? What about privacy coins?
Well, I think the coins that will survive long term are the proof of work based coins. That's the honest signaling. That's the gravity that draws us together. So I don't think any proof of stake system will last. This is now moving from, this is my conjecture, my opinion. I think Atomicals definitely makes the alternative coins like the proof of stake or just other tokens on other blockchains just a lot less appealing. Like, why would you have a token that's backed by just a data file that's not backed by Satoshi digital gold? Like, why would you not do that? Why would you not back your token by the #1 blockchain with the highest proof of work beacon? So I think Atomicals definitely starts to shift will shift the narrative in what it means to launch a token and what it means for other blockchains to even exist. I think other proof of work blockchains will actually, I think there's a very good, compelling case for others to exist. Bitcoin is digital gold, but it's not geared towards micro payments and certain kinds of smart contracting, or Atomicals is kind of that bridge. And so long term, I see a bright future for altcoins that are proof of work, that have advanced smart contracting capabilities, but I definitely see other altcoins that don't have any unique value proposition, just not having a reason to exist. Privacy coins, as you mentioned, of course do exist because they're shielded, or they're private, using zero knowledge proofs baked in at the beginning. They have their niche, a very important niche that's growing, that I think will continue to be important as well, provided they're proof of work, as I mentioned earlier.
Right on. I agree with you. I think the vast of the Crypto Vigilante agrees with you as well. So quick summary, please. How do Atomicals work, and why they can't get spoofed or attacked?
Sure. So what basically what an Atomical is just a chain of digital signatures. So once we create the mint event, just like any other any ordinal or any NFT, you can just trace through the spends to arrive at the latest state. Now, let's say we have a realm or Atomical that has, let's say, 1,000 or 10,000 spends. Okay, let's say we have 10,000 data updates. Well, if you multiply that out, 10,000 transactions times, let's just say 500 bytes each. What is that? 500 kilobytes? Or is it 50 kilobytes of data? It's under a megabyte. So if we really don't want to trust an indexer, well, you could just download the data yourself into the browser, into the client, and then run the updates forward yourself, and then you have the data validated because you checked it yourself. On the flip side, we're hoping that people will just run their own decentralized indexer in the same ethos as Bitcoin itself. Run your own node, validate your own history. If you're doing that, and you have a service or an app, you're just going to run your own decentralized indexer, which I completely forgot to mention is ElectrumX. I don't even know if I mentioned that explicitly. We based it on ElectrumX. Everyone's basically already using ElectrumX for years. It is battle tested, high performance, robust, WebSockets enabled, and so that's why we went with ElectrumX. And so you just run your own ElectrumX, and it validates your own history. If there's a discrepancy, we could just check the Atomicals block hash. It becomes out of sync with your peers or with other people, other services, and then you would be able to find the problem immediately. We could fix the problem, and everyone, would get that latest update pushed out immediately, and not wait for some proprietary, marketplace to do whatever update they do, and just kind of force us to go along with it. That's what we have with Atomicals, is decentralization, and that just means openness and trust but verify.
Awesome. Question: why would I use containers tonight?
Well, the reason to use containers is because it's simply the only way to organize an NFT collection on chain at all. Like, so if you don't want to, we use containers because then we can replicate the collection name, the metadata, the items in the containers to everyone at the same time with no, you don't need to run around to a dozen marketplaces and submit a pull request or a submit a ticket with your text file of all the NFTs or ordinals that you have, and then find out later that they have a typo somewhere, or you submitted duplicates. No, you just use the containers. You can validate that you've added things correctly. And when you've done, your team has signed off on it. The items are correct, the metadata is correct, and you go, you update, you seal, you're done forever. And everyone else will have the exact same snapshot of the data and that's why you'd use containers. And of course, you'd have a really cool vanity container name that no one else can take, and that will be your unique hashtag or identifier that shows up in all these other services.
Right on, right on. I have a cool question here. Could a chain like Radiant be useful for an association with Atomicals, given the block size and zero conf and L2 potential, being L1 and derived from Bitcoin code directly?
Absolutely.
Okay.
Absolutely. So,
what about, so pretty much any UTXO blockchain could adopt, because there's also Doginals, right? Like the Doginal marketplace exists on Dogecoin. So I guess Dogecoin can adopt Atomicals as well, right?
Absolutely. And so Atomicals was built with that in mind, that others would port it to the other UTXO blockchains. What's interesting about a blockchain like Radiant is that Radiant has really the richest and most comprehensive smart contracting capabilities. So that means you could create L1 locks, L1 rules in Radiant that enforce the transitions in L1. So the miners would actually end up enforcing the Atomicals rules. So it's not just like the indexer is performing the updates, but the indexer would almost kind of just be a dumb indexer, because Radiant would actually have the miners that validate the transitions are correct. So there's like an element of extra security and extra expressiveness and complexity that can be done with these blockchains that have the more advanced smart contracting capabilities that are in the UTXO blockchain. So we hope that in the future that Atomicals becomes a global consensus engine, and that means that we treat Bitcoin as digital gold, as the primary proof of work beacon, but also be able to take the Atomicals and bridge them, or how do you put it, have them overlaid across multiple chains. That would be the future vision. So something like Bitcoin would be the backbone, and then we'd have these side chains, or I don't want to use side chains, but like sister smart contracting chains like Radiant or Doge Atomicals, for example, that would then complement the primary proof of work beacon. That's actually what we really, really hope will emerge, and that's what we're actively thinking about for the future.
I wonder what the Dogecoin community will call this, like puppy Tomicals or something. I don't know. Kibble con. I don't know. Anyways, on the Radiant topics, since being 100% proof of work, could the proof of work of Radiant be used with GPU for mineable tokens or NFTs?
Well, the Bitwork protocol does not use the SHA-256 of Bitcoin, nor the SHA-512 of Radiant. It uses a different technique of using the prefix matching of the TXID, which we'll expound on later. So the short answer is no. The mining algorithms are completely different, and it has to be that way, and that's actually a really good thing. But from another angle, any proof of work, like GPU-based proof of work and research into proof of work, the tooling for proof of work of Radiant, of Bitcoin, it can be leveraged and moved over to mineable tokens in this new form. Yes, it's a different algorithm, but a lot of the concepts and the workflows can be ported over, and the mining kernel can be adapted so that we can basically kick off a whole era of GPU mineable tokens. And so certainly it could run on Radiant and Bitcoin and these other blockchains as well. And that's our hope. That's why we think proof of work is here to stay, and in fact is really the solution that we all want.
Right on, right on. Why are you guys doing this?
The love of humanity. We really want to create a world where we own our digital lives. We want to create a world where we have control and sovereignty. We want to create the future that we believe we all deserve. And this is a work of love for the world and ourselves, and it is a gift for the world. And it's really darn cool. We love the vibes, and we love the community. We love the support. And this had to be created. This has to exist. This is a next step forward. And we're just so grateful that we're at this point where we can unveil it.
So there are a lot of protocols being unveiled for the ordinals that complement ordinals protocols, right? Like you see a lot of them within the ordinals architecture and ordinal theory. Why did you choose this summit to unveil Atomicals to the world? Why this summit?
The biggest is the our vision of the future, our values of personal freedom, liberty, sound money, and that's really the driving force is our values. Yes, it is. We're talking about NFTs and tokens. So, but there's a lot of conferences. There's a lot of things going on that are talking about in this space, but none of them shared our values. And so to present here is an honor, because it's really about our values and our alignment to the future that resonates.
That's awesome, man. That's incredible. For developers out there listening, where could they go to start incorporating, and how can people get ready? Because you're launching here. You're giving people a heads up to get ready right now, because in 24 hours on block 808080, Atomicals is going to be possible, is going to launch. So how can we get ready for that right now?
That's right. So head on over to github.com/atomicals and download the Electromex indexer. Later today, I'll be making a snapshot of an updated database, so you don't have to sync for the couple of days. You could just get that blob and then plop it off into a virtual machine or a server, and start and just run. And then you have the Atomicals-JS JavaScript library, the command line utility that you saw in the demos, that are also there. And just start poking around there. Run Clyde --help. You're going to see the options available. I know it's going to be overwhelming, and I know the documentation is it's going to all come tonight. So we really did everything to make the announcement tonight, and we're going to do everything possible in the next 24 hours to completely build out the guidebook and all the resources. So developers that are listening right now, please, we love to have you join us. Head on over to the GitHub. If you have any questions, ping us on Twitter. Just reach out to us. We want to help. We want everyone to be on the ground floor for this launch, which is on the 17th. So just a little bit under a couple days. So, but let's all get ready as much as we can and help each other out to prepare for the inaugural atomical number 0.
That's amazing. Okay, so what applications, what do you see coming out of Atomicals that is significantly different from what we've had with Ordinals? Like what applications, what protocols, what do you expect to happen? What do you envision?
It's a great question, and I'm glad it's asked. Well, two of the major things that I think are going to be really innovative is this inter-agent or inter-indexer communication. So imagine that you're running your own Electromex, but with your own set of meta rules, and you could publish an on-chain contract that the other indexers can interact with. So you can create very complex games, very complex NFT collaborations, and other DeFi-like things where you have automated agents interacting with each other. They're listening to their event feeds and reacting in real time, making payments and minting things dynamically based on certain triggers. So I see that kind of complex programmable interactive environment is now possible. That's kind of abstract, but something more concrete is, let's just replace Twitter. Let's
Mm.
leverage Nostr and these other protocols, and let's use Atomicals and digital objects to just create our own world. We don't need the domain name system anymore. We have realms. We have a realm name system that is Bitcoin blockchain native, that is robust and actually could be mainstream with the plus sign. We don't need to worry about GTLDs and all that. We have a world and we chart our own path to where we want to go. You can't say a project is decentralized and we live in this decentralized world when everyone's still using DNS. Like that's doesn't work. We have all these kind of onerous authoritarian digital ID systems just right around the corner coming at us. And here we have a beacon of hope to forge our own path. So that's what I think we're going to be able to create, is our corner of the internet that will then radiate outwards and show other people what true digital sovereignty and ownership looks like.
Okay, this is a very important question, but what do you envision to be the top 3 criticisms regarding Atomicals, and how would you answer those misconceptions?
Sure. The first criticism I would level against Atomicals is what I've mentioned that before, is that we don't index the existing ecosystem of ordinals. So there's no ability to say burn an ordinal, revive it on Atomicals and send it back, like asset teleportation. I think that's either, depends how you look at it. It's either important or not. But let's just say it's very important to be able to leverage. Basically, the message of that is it's important to leverage what exists, right? We're not going to throw away what came before. There's no way for that. No, we have a beautiful economy that's growing massively in ordinals, and we're going to complement. That's why we have containers. That's why we have realms, and the protocol is completely general for key value storage. You can reference any IPFS resource, any web resource, any legacy internet, but also any token, any existing Bitcoin economy. So that's what I would say. The counter is that we don't have to create this massive unified thing. We can work together. So, but that is I can already hear other people think this, because I think this too, owning many ordinals myself, is like, okay, well, I want to use those ordinals in my Atomicals projects. That's just how it's going to have to be. So that's one objection, is that we're not replacing anything. We're complementing, but also providing another avenue. The other complaint or downside, I'd say, is that, well, how programmable is Atomicals really? Like, there's no programming language in there that allows us to create really, really rich smart contracts for now. So right now, Atomicals is exactly the building blocks and the composability that we need to make that quantum leap forward. So right now, we don't have, like in other, like say EOS or Ethereum, we have Solidity and we have WebAssembly. Well, Atomicals is intentionally kept simple. If you think of a spectrum where you have like full complex Solidity or scripting capabilities on one end, on the other end, you have the simplest, most elegant digital artifacts of ordinals. Think of Atomicals on the spectrum where it's like 2/3 or 3/4 the way to EOS or Ethereum Solidity smart contracting. We just stop short of all that complexity, where it just becomes an entire virtual machine beast on its own, and then it's just we don't have any of this composability kind of is replaced with a complete smart contracting engine. So Atomicals, the downside is it's not that powerful at the high end for now. But looking to the future, this is actually a necessary building block if we want to get to the future where we can have arbitrary consensus at scale. We actually need something like Atomicals as the base operating system, if you will, or base layers to then get to the next level. So that's what I'd say is a downside right now with Atomicals, but this is a phase, right? This is you can, I think people can see where this will go once we launch. So that's the second criticism I have, is that we're basically, I'm saying we're not Ethereum, which is, I think it's a pretty decent, we're not EOS, or we're not the advanced scripting capabilities of, like, say, BSV or BCH, we're not Radiant. Like, we didn't reinvent Radiant in L2. That would not make any sense. All these programming environments, these blockchains have powerful scripting capabilities. We're providing that structure so that higher order organization can emerge and for what comes next. Nice. The third objection or third downside I can think of, if I were to really try to pull something out of from here, is honestly, I can't think of a third. I really can't.
It's all good. Whenever I ask this type of question, most people can't get to the third, but I ask for three so that they really dig deep. I'm trying to think as much as possible, and to tell you the truth, like, if someone can, I'd actually rather put it back to the person who asked, or the people who asked. I'd actually like to hear from people what they think would be the downside, because that's actually going to inform us for the roadmap and the future. So I'll just, swing that back to the audience of what you can see or perceive now or in the future to inform us, so that we can then help with that. Right on. Awesome. And I got one last question for you. Can the Atomicals JS library be inscribed onto Bitcoin? I haven't checked. In theory, yes, and practically speaking, too, I don't see why not. It's probably a good idea to trim it down, lean it down, right? Like, tighten it up so there's not so much bloat, because every byte counts, and then that way we can get it into a package. You could use recursions. You could use recursions. Absolutely. Yeah. Yes, absolutely. And so, like, because I mean, like Ord.io, right? That's like the window into like the Ordinals universe, and you see everything being inscribed in real time. Well, like, someone's always watching that. Everyone's learning to look at the blockchain. Like, people are like starting to, like, forget Twitter, forget anything else. Like, I'm looking at the blockchain. Like, what's the blockchain telling me? How is it speaking to me? What are people saying? So yeah, dude, it would be really cool if you put it up in there. That would be really great. That's yes. The composability and the immutability would make this even better. Right on. Atomicals, it was an honor to have you here. Thank you so much for your time. Likewise, thank you so much for having us, and it's an honor to present here. Thank you so much. We love what you're doing, and it's an inspiration, and that's why we're here to be a part of this. Dude, I'm so happy you're doing this. Yeah, follow Atomicals and get ready for the launch on block 808080. Thank you so much for being with us. Thank you. Take care. Bye-bye. Okay. Bye-bye.